Alright, factoring completely, and I left you with two problems to continue on by yourself. So, did you find a GCF for 12x cubed plus 24x squared plus 30x? And let's take a look at this. Let's look at the smallest one. 6 times 2, 3 times 4. Well, I know 6, the biggest factor I can think of other than 12. 6 will go into all three of these. So let's go with 6. And x cubed, x squared, and x, so we find that lowest power of x and pull that out. Let's get our big parentheses ready and put our leftovers inside. 12 divided by 6 is 2, and x cubed divided by x is x squared. Now my plus sign. 24 divided by 6 is 4, and x squared divided by x is x. Now 2 and 4 still have a common factor, but if we don't have a common factor in the third term, then we've done our job. We've factored out everything we can. Alright, the minus sign, and then 30 divided by 6 is 5, and x divided by itself is 1, and we don't write times 1 down. Alright, so looking at 2, 4, and 5, there is no common factor, so we are done with this one. Now, we could attempt to factor it into two binomials, but it's not in x squared plus bx plus c form. We have a coefficient on the x squared that makes these a little bit more difficult to factor. And sometimes it is possible to factor them when they do have a coefficient, but I just know in advance that this one is not factorable any further, so we will stop there. Alright, x squared plus 16x plus 36. No x's in common. No numbers in common, because there's just a 1 here, and that would be the biggest number I could pull out of all of them, and there's no point in factoring out a 1. So the other thing we can do is look at factor pairs and try to factor it into two binomials. Let's see if we can do that. We're looking at 36 here, and we're looking at 16 here. So we're looking for factor pairs of 16 that add, factor pairs of 36 that add up to 16. So I'm going to go to a separate sheet of paper and make a factor rainbow for 36 and start checking out those factor pairs to see if any of them add up to 16. So 1 times 36, no, 36 plus 1, they'd both be positive, by the way. That's not going to work. 2 times 18. Again, with both of them positive, if one was negative, then we could get 16, but that's not going to work. They add up to 20. 3 doesn't go into 30. Oh, yeah, it does. Sorry. 3 times 12. No way they're going to add up to 16. 4 times 9. There's no way they're going to add up to 16. And 6 times 6, and they don't add up to 16. Guess what, folks? This one is not factorable. It's already in the simplest form we can get it, and we can't factor it. So I hope you didn't dwell over that one too long. That was kind of a nasty trick to make you do that one on your own. But that will happen occasionally. You'll come across a polynomial that's not factorable. In fact, it will happen a lot. But not in this class.